Now in this segment we are going to be taking a look at the calculation of the pH of a solution when a salt has been added to it. So in this question, where we are calculating the pH of a 0.15 molar solution of potassium acetate, we have to first of all analyze the salt just like what we did in the previous example. When we look at potassium acetate, we recognize that the potassium comes from KOH and the acetate comes from acetic acid. Since KOH is a strong base, we can conclude that the K plus, or the conjugate of the KOH, is not going to do anything. However, because we know that the acetic acid here is a weak acid, the conjugate base, which is the acetate ion, will react with water. So from that analysis, we can then begin with writing our equilibrium equation. So we focus in on the acetate ion reacting with water, giving you acetic acid plus hydroxide ion. Now notice that I did not write the K in here, and the reason is that I know that the K is a spectator ion, so I am safe to ignore it and just leave it out of the equation. It is still in the solution floating around, but it's not doing anything. So now that we've established our equilibrium calculation, our equilibrium equation, we can now go ahead and generate our ice chart. And so we put in 0.15 molar of our acetate ion, and then we have 0 amount of acetic acid, and we have 0 amount of hydroxide. So we minus and we add on the other side according to Le Chatelet, so 0.15 minus x, x, and x. So now, since we are forming a base, we know that we cannot use the Ka, and so what we need to do is we need to use the Kb of our acetic acid. So the Kb is going to be 1.0 times 10 to the minus 14 all over 1.8 times 10 to the minus 5, so it's going to equal to 5.6 times 10 to the minus 10. So now we can complete our equation. Now because the 0.15 is significantly bigger than our Kb, then we can be safe in assuming that the amount or the value of x is going to be very small and therefore negligible. So if we were to solve this, x turns into 9.2 times 10 to the minus 6, which is the concentration of the hydroxide ion. So if we now take our POH, which is negative log of 9.6 times 10 to the minus 6, we end up with the value of 5.04. So now pH is going to be 14.00 minus 5.04, and thus we end up with 8.96. And so the key to completing this is not so much as you knowing how to do the math, but rather the key is in setting up the correct equilibrium equation, and that comes from a proper analysis of the salt that you are adding to the solution.